Hello, my name is Alexei Pukhov. I was a previous PharmD and current master's student, and I am doing research using data science for using R in the current pharmacy sector. And during this time, I've learned quite a few skills, and I want to be able to give back these skills and to help other people also with their data science journey and improve on their skills in order to basically help in whatever industry you're working in. So this will be a practical application on how to use different data science concepts and techniques in order to make value out of the data. So for this very first session, I'm going to be using some data that I've downloaded from Kaggle. If you don't know, Kaggle is basically a site for data science, and it contains people that have posted their solutions with their code as well as example datasets. And I downloaded one of the top rated datasets, which was house rent dataset. And we are going to be using that for some basic analysis so that you can get the ropes about how to do some analysis using R. So first of all, let's just create an R file. So I've already made a file named education here. And I've also made a new project file. So if you go over here and then to new project, and you click existing directory, and you go over here for education, and you create project, then it creates a new project for you. What the project is good is that it's really good at opening up the same files that you're accessing and the same data sets when you switch between different projects. Now, this will be more important as you go down the road and you make lots of files because it will help with your organization. If I have the chance, I will show that to you in a future video. So to begin with, we're just going to start making a new R file. And as you can see, there's a new R file. Before I begin with this, you might notice that my IDE is black, of course. There's also always this debate in the programmer community about light IDE versus dark IDE. Light IDE is, for example, where the background is white, and black IDE is where it's black. In my case, I'm just using the black IDE because I feel more comfortable with it, and it makes me feel kind of cool, like I'm a hacker, you know. So if you yourself want to change it, then you can go to Tools, Global Options, then you go down to Appearance, and here you can just change the editor theme. So mine is on Tomorrow Night Bright, but if, for example, you change it to Solaris Light, then you can change it. So you would hit apply here for it to work. So for example, I'll show you. So this is how the light theme works. It's pretty horrible in my opinion, but changing it back to the black IDE, this is how it looks like. Okay, so I have in this folder that I've made education, I have the house rent dataset. And in the house rent dataset, if you want to see how it looks like, first of all, if this is your first time using R, or if you don't have a lot of packages, you're going to install a package named Rio. Rio is basically a package to help you import different files of different types. So it'll install packages Rio, and then it installs Rio, and then you're going to call library Rio in order to put it in use. So the thing is, you only want to install a package once. If a package is already installed, then you'll see it under here. For example, Rio. Where is it? Rio, here it is. So if you have the package already, then it'll be checkmarked that you have it. If you can find this file, then you're going to do install packages. Now, once you already have the package, you don't really need to install package again. You just need to call library Rio in order to be able to use it. So what the Rio allows us to do is it allows us to import files of different file types with just a single command. So Rio is a package, and R has tens of thousands of these packages run by different people that basically extend additional functionality to R and allow it to do a lot of different things. So in this case, one of the functions of R is import. So let's name our file house rent Tibble. This is just a naming convention that I use. Basically, some descriptors of what the actual data set is about, and then the format of the data. So in this case, it's a Tibble, and in R there is the data frame, but then that was replaced by the Tibble, which is a newer addition to the data frame, which basically allows it to be faster and more lightweight. So in our case, we're just going to set this to import of this file, and you can see the files in this folder right here that I have in this education folder. It's a house rent dataset.csv. So we're going to import that and make sure it's in quotations because it's a string. So house rent dataset.csv, and we run this, and then we have this file in. So in R, the order of the panels might be different in your version of R, just because mine is personalized to me. So you can move these panels around. So this can be in the top right, and this can be in the top left. So this environment might be here for you. But in this case, you see this is house rent Tibble, and you can click on it in order to have a look at what the data looks like. So this is how the data looks like. So that was posted on column, BHK column, rent column, size column, floor column, area type column, area locality column, city, furnishing status, tenant preferred, bathroom, and point of contact. These are all columns. And then if you scroll down, these are the row numbers here. You can basically see that this is around 4,700-ish variables. And there's a lot of information, but we want to make basically some insights into the data and to be able to understand. So what's the biggest... for example, what about the number of bathrooms and what's the average price? So let's say you want something of size and tenant preferred. So you want to see if there's any difference in size between the size and the size, bathroom, and rent, let's say. So you're interested in these three variables: rent, size, and bathrooms. So let's go over here. So first of all, this is our house rent table. And one more thing, if you want to do any data wrangling in R, you want to be able to use the Tidyverse. So like Rio, I already have the Tidyverse installed, but the Tidyverse is essentially this legendary package within R, which is a meta package of other packages, and they allow you to basically do data wrangling in R. So I already have the package installed, but in case you don't have the package, then you can just call install.packages Tidyverse. So I will just get over here. And if you want to run a line of code in R, then you want to press Control plus Enter. So it installs the package. And you can actually see the packages that are here and here. Tidyverse, ggplot2, that's for making graphs. Tibble, which is Tibble's what I just call Tibble's tider, deployer, stringer, and forecast. And I'll get into these eventually in later videos, but right now we're just going to do some simple analysis. So let's just do from house run Tibble. House run Tibble. Let's do, so at first we're going to use it. And so this is the pipe symbol. And this pipe symbol is part of the Tidyverse package. It was from Magitar, but you're not interested in knowing that. What it basically allows you to do is to move the data into the next argument. So when you call some kind of argument, so let's say mutate data, and then the column that you want equals new value. I'll explain the mutate later. But essentially what it does is that this house run Tibble here actually goes into the first one, into the data. So that's going to be used by the vectorized function. So mutate is a vectorized function, and vectorize is just a fancy name for basically go through each row in the entire Tibble or entire data set. So first of all, we're going to actually not use mutate, my bad. But let's say you can say view in order to look at the same thing that we did before when you clicked here. So I'm also going to just explain my programming philosophy. So the way that I tackle problems is that I view it as kind of broken up into two steps. So first of all, you have the basically thinking that allows you to break down a bigger problem into smaller problems. Now, the way that you fix those smaller problems are that you use tools from your toolbox. And the tools in your toolbox are really the syntax that you've memorized or the functions that you've memorized. So, for example, you've memorized view, you've memorized mutate. No, well, not really. You memorize view, you memorize import. So next time, say that your boss actually sends you some file and you don't know how to do it, but you have to put it into R. So what would you use in that case? Well, you would break down the problem. Okay, I have to get the program into R. What's a function that I can use in order to get it into R? Well, I just taught you about the import package. So you come up to the conclusion, oh, I can just import the package that my boss sent me. Oh, what's the name of this package? Oh, I remember I have to put it into quotations and put the name of the file that's in the same project that I've made for the file. So that's how it basically works. So first of all, let's just use group by. So what does group by basically do is it groups by a common variable. So let's look at a common variable here. So bachelor's family is a common variable. Bachelor's, these are all common variables. So what group by does, it takes basically it groups by that variable. So all bachelor's family would all be one group. All bachelors would be a group, and it performs vectorized functions on each group at a time and gives different calculations for each group. So I'll show you what this means in practical terms, not just theoretical. So let's say we wanted it to group by tenant preferred. So we're grouping by tenant preferred. Tenant preferred. And then after we group it by tenant preferred, say we want to get some easy statistics about, okay, so for the apartments that have a tenant preferred status, say bachelor's or bachelor's family, is there a difference in the mean rent price between these? So in that case, what we can use is that we can use the summarize and we can use the mean function. So, for example, summarize takes basically all those groups that you've made and performs vectorized calculations on them. So let's say summarize, the average is the mean of, say, let's say of rent, right? So it's the mean of rent. And, well, I just screwed this up, but that's what happens usually in programming. So you actually don't want to, well, set it as the same date frame as before, because then you're just going to overwrite your date frame. So in this case, I'm just going to run this line again with Control plus Enter, and then Control plus Enter this line again. So because it uses the pipe symbol in all of these, it runs all three of the codes together until it reaches a point when there's no more pipe symbol, which means that it's already reached the end. So in this case, we run this, and we can see that there's basically a difference in the average of the mean rent price. So the mean rent price, if it's bachelor's, is 42. Mean price of bachelor's family is 32,000, and if it's family, is 50,000. So you can make some conclusions or insights from the data just by that. But let's say that we didn't want to just group by tenant preferred. We also wanted to group by, say, area locality. So let's group by area locality. Area. And in this case, I'm using autocomplete. So what the autocomplete in R is that when you start writing something, if it matches, well, a column that you're trying to search for or function you're trying to search for, it will open up different options for you to select. And then you can just move with the arrow keys, which one you want, and press enter, and it completes it for you. So in this case, I'm looking for area locality. Go to area locality, and I want to see the mean of the rent price. And as you can see, the area locality, the average of the area locality, has quite a lot of rows. So we were able to reduce this data frame from 4,700 to around 2,200. So it means there were some group variables or that had the same area locality. But we don't want to see the data like this. Well, we want to, I'm a very visual person, so I am an auditory person, but I'm also visual, and I find that seeing the data visually helps me a lot, and it's something that I really appreciate from R. So what we can do is that we can pipe this into view, what I just previously showed. So if we run this again, whoops, press delete, press Control Z to undo, then, and then we go over here. I'll just close this. And goes like this. Then we can see that all of the summarize that it has here. So let's say that we also want to, like, this is a lot of data, and the only way that we can make sense of it is, say, if we arrange it by basically price average. So what we can do is just click this and see it gets you the average, which is just a variable that I named, which is the mean of rent. So for example, in this place over here in Rekaja RTC Worley, it's a really high amount. Or Bandra East, it's also a really high amount for the mean price. But so in this case, instead of clicking on here, say you wanted to put it into here. In this case, you can use arrange. So you want to arrange it in basically descending order, with the highest being on top and the lowest at the bottom. You want to make it into descending order of the average variable. So you're going to put in average as the negative variable. You put a negative in front of average. So the thing is, if you just do this, then this is an ascending order. So you would have the lowest value at the top. But if you do it like this, you reverse the order, and it basically goes descending order with the highest at the top. So if you run this now with Control plus Enter, then you can see that it gives you basically the same results you had before, with the highest on the top. And so what you can also do is say that you're not interested in basically all these results, but you only want the top 5. So since you already arranged this, you basically only want the top 5 rows of the resulting Tibble that you got, right? So in this case, what you can do is slice. And what slice does, it reduces, it only gets the row numbers of the data frame. So in this case, if you do slice 1 to 5, then it would get only the top 5. And since you've already arranged it, that means the top 5 rows of the resulting data frame will actually be the top 5 mean of the rent prices. So if you also do a pipe simple here, in R, you can a shortcut for the pipe simple is Control plus Shift plus M, and that's a very useful shortcut. So if you do Control plus Enter, you can just see just the top 5 prices for the area locality and average. So now let's do something more complicated. So let's say that you want to group by city. Are there different cities in this data set? Mumbai, yeah, by city, and you want to see what's the average and what's the max and what's the min rent by the city, which makes more sense than using this area locality, which I'm not sure. So in this case, we use city and rent. So what we're going to do is we're going to group by city, and we want to see what the mean prices are, what the maximum price is, and what the minimum price is. So we can set the max equal to the max of. So this would already work for the average. The mean of the rent prices when we already group by city, that makes sense since it would give us the mean of in the city. But we also want to know some additional statistics. So let's say the max is equal to the max, which is another function, max of the rent. Whoops, make a lot of typos. Okay, there we go. And then we put a comma here saying that you want more additional arguments. So let's say the min is equal to the min of rent. Min of rent. And then let's say the standard deviation is equal to this SD of rent. And then we put another bracket here indicating that our expression has ended. And if we do this now, whoops. Oh, in this case, we don't want the slice. Let's do the view as well. Or actually, let's remove it for now, just to see how it is without. So, and then if we run this with Control plus Enter, we see some statistics for the different cities. So it seems in our basic data set here, 4,800, we only have 6 cities. And you can see that the highest average rent price is Mumbai. And the maximum price also is actually not by Mumbai, but it's actually Bangalore, right? And you have a bunch of statistics now here. But say you don't want it to be in basically average, descending order based on average. You want it to be in descending order by max. So in this case, you do arrange negative max, right? And then Control plus Enter. And then it gives you the same statistics, except now it's in descending order of max. So let's say you also wanted to view this. You can just write view. And there it is. So let's see, what else can we do with this data? So let's say you want two variables. So you don't want just city, you also want city and furnishing status. So perhaps the units in the cities, depending on their furnishing status, are different. So in this case, you want to group by two variables since you're interested in two variables. So in this case, you'll group by city, but also by furnishing status. I can just do furnishing status, and then it'll give you the statistics and no view, and it gives you everything. So as you can see that there are, for every city, there are two statistics for every city. And let's put this in negative order by city. Can't arrange. That's fine. For now, let's just do negative average. Okay. So in this case, we actually see Mumbai is once again leading. Mumbai has the highest average prices, but these are mostly being driven by furnished in Mumbai, right? And you can see, but it's not the one that has the highest max. Actually, Mumbai semi-furnished has the highest max, with also the highest standard deviation. Probably because of the max, it's so far from the average, which is why the standard deviation is so high. And then you can see all of the different cities here as well. So now let's say that before I finish this, I also want to introduce a new type of column. So what we can do is we can do some feature engineering to basically hack our way to more data from the data that we already have. So let's say that I'll show two sample. So let's first of all, size is let's divide size by 100 and then get the average of size. So instead of getting the mean of size, or actually that'll probably also good, let's get the mean of size. That should be a comment. Mean of size. Size not found. Capital. Okay. That should work. There you go. And the mean of size. The mean of size. Mean of rent. No. Sorry. So this is the average rent. Put descriptive names. Average rent. And this is average size. Average. Average size not found. Object average. Right, that makes sense because there is no average. So we do arrange by negative average. Let's do average rent. Run this. So there you go, and you see the average sizes here as well. Now, but in this case, let's change, or let's make it in the average rent. I'm guessing this is in dollar amount, so let's make this average rent in $1,000 in 1,000, and it will be the mean of the rent price divided by 1,000, right? In this case, average rent not found. Mean rent. Mean rent. Here, 1 second. Errors all the time. Average rent not found. Ah, right, because I changed the variable name. Average rent in 1,000. Mean rent divided by 1,000. Divided by 1,000. So now average rent in 1,000. You can see this is 109,000 for Mumbai, right, with the furnished, because we can see that so much. So that's actually not mutate, but that's just another example. So let's say, okay, I'm just going to copy this, and I'll show you mutate. So mutate allows you to basically either make a new column or override a pre-existing column. So in this case, let's say that rent, here, let's say that the rent prices are just too damn high, right? So in that case, we're just going to reduce it by 1,000. So mutate, we're going to set mutate rent, the rent column. The rent column is equal to its current value divided by 1,000, right? And we don't want to do house rent Tibble, and in this case we actually do want to set the new state to a variable, so we're going to set hen Tibble is equal to house rent Tibble divided by 1,000. So we're going to set that new, and then if we look at over here, we can see that now our rent is in thousands, and I didn't set it. So in this case, you can rename it, but I'll show it later. So in a later video, I'll show that in a later video. So now we want the original data back, and double check it's the original data. It is original data, and I'm just going to undo everything that I did. Okay, there you go. So now let's say summarize, and in this case, average rent. Yeah, okay. Let's see, what else would be interesting here? BHK. So you also want to see what the, let's say you also are interested in basically the difference between, you're interested in the difference between the maximum and the minimum for all of these variables. So let's say, so what you're going to do is you can now mutate basically your new result. So let's say mutate, and let's call this variable diff between max min is equal to the max column minus the minimum column. And essentially, because this is a vectorized function, it goes down all the rows. So now you can run this, and you can see that the difference between the maximum and minimum seems to be the highest in Delhi. Is it Delhi? No, sorry. So it's not Delhi, it's Bangalore. So you can see in Bangalore, for semi-furnished, that the difference seems to be highest. And it really stands out now. But previously it also stood out, but I didn't pay attention to it. But now it really stands out. So now you can see the difference. And you can see that its minimum price is 4,000, maximum is such a high number, and of course you can see the difference between the max and the minimum. So this has just been some simple deep data wrangling operations, and in future videos I'll go over additionally more.